Okay, so for page 2 of your HBL worksheet for electricity. Now, for question 5, the question asks, which one is a possible current at the junction? So before we do this question, let's revise a bit. Remember that the current that enters the junction, how much current enters the junction, the same amount must also leave the junction. Junction means a point, basically. It's nothing, it just means a point in the circuit, because current cannot just disappear or multiply. So what it means is that if you have something like this, so the current that enters this point is 5 ampere, the current that leaves must be 5 ampere. If there is a split, the current that enters is 5, let's say, and then the current that leaves, you add together, it will also be equal to 5. Or it could be 1 and 4, or it could be 2.5 and 2.5, right? So how much current is in each branch? Well, it depends on what is the amount of resistance here. But whatever it is, you add up these branches, it should be equal to this. So with that, the only one that fulfills this criteria is B, because for B, 5 ampere enters, and the amount that leaves is 2 plus 5, and that is 5 ampere as well. For question 6, again with the same concept, right? So the current that enters this point is the current shown in ammeter A1, and that is split into 2. So the current in A2 and A3 in the ammeter shown here should be equal to A1. So A1 equals A2 plus A3, right? So this branch plus this branch. And then they go back again, they join together, they go back, so that's equals to A4. So then the answer should be D. In case you have chosen A2 and A3, this is a common mistake that students make. The thing is, you notice that the two branches are not quite the same. This branch has more resistance than this branch. So when the current split, they may not split equally. And anyway, they also didn't tell us the value, so we cannot assume that the resistance in both branches are the same. So this cannot be the answer. Question 7. Question 7, same concept. In fact, 5, 6, and 7 is all the same concept. So the current here is 4 ampere. It reaches this point, it splits into 2. So if 1 ampere flow through the first branch, the second branch will be 4 minus 1, 3 ampere. This one, it looks a little complicated, but no worries, it's the same concept. The current comes up, reach here, splits into 2, and then join back. So when it splits into 2, this is 5 plus, I don't know what this is, 5 plus A2. Then they join back. Now I have written 11, but don't worry, you're not supposed to know yet. So 5 plus A2, maybe I'll just write here, 5 plus A2 equals, and then this amount of current split into 2, so equals to 4 plus 7. Okay, so then these two branches is added together is 11. So I know that when they go out, this is 11. So it'll be 11, 11, 11 here. So if it's 11 ampere coming in, and this is 5, it will be 11 minus 5. For question 8, let's zoom into the 3 circuits. This is circuit A. Now, the question asks, what happens when you take out W? This is a parallel circuit. If you were to, but these two light bulbs are in series. So if I take out W, this one cannot work anymore, because in this branch, the current cannot pass through this light bulb if this one is taken out. So in that case, but the current can still flow through this one, because the current will go like that, like that, like that. As long as it has a complete path, the current can flow. Okay, so there is one light bulb that will light up. This is a series circuit, so when you remove one, everything cannot work, because you basically cause a gap inside the circuit, and then the current will not be able to flow anymore to any of the light bulbs here, so 0. Now for this one, 3 branches, so this is parallel circuit. Do remember that the advantage is that the bulbs can operate independently, which means that when this is taken out, I still got 2 more branches, right? So this branch here, like that, one complete path. So yes, this one can light up. This one, another complete path. So this one also can light up. So 2 light bulbs can light up. And therefore, I will get my answer here, B, C, and A.